Okay, next one I will give you the example of non-existence of limit, when the limit doesn't exist. Okay. The first example, see, let's say I want to find the limit of 1 over x power 2 when x approaches to 0. Okay. When you plot graph, in this case when you plot graph, our x power 2 is always plus, right? So you can replace it when you plot graph, replace x when x, of course, shouldn't be 0, right? Our denominator, if equal to 0, become undefined again. That we learn the function of this one. Say function f of x equal to 1 over x squared. When you this one when you plot graph, gonna have like the asymptote, horizontal, vertical asymptote equal to 0. That means when you replace x equal to 1, right? Equal to 1, your y gonna be positive, right? If equal to 2, y gonna be 1 over 4 and so on until plus infinity. And if x equal to negative 1, you replace negative 1 gonna be plus sign, gonna be negative 1 gonna be somewhere here, and the 2, negative 3 and so on. So the graph come out above x-axis. Okay, so then we find out we have actually this one is what? Vertical asymptote. Okay, and then we broken line. So that means our graph will approach closer to 0. Okay, so then in this case the limit, the answer of limit 1 over x squared when x approaches to 0, it doesn't exist, right? This one doesn't exist. Or another word, we can answer this one. You can see because the graph approach closer to above here, right? This is supposed to be infinity, right? So you can answer this supposed to be infinity also. Can be either way, right? Because if you answer positive infinity, it's can see picture, but then from the left and from the right hand. Okay, from the left hand limits and from the right hand limit, we approach closer to positive infinity. Okay, so now see the next example. We find the limit of absolute x over x when x approaches to 0. In this case, you still remember our definition of absolute x. We have two kinds, right? That means when x greater than 0, this one gonna be equal to x when x greater than 0, and this one equal to negative x when our x less than 0. Okay, so that's why when you plot graph, you will get this one. Again, this one x approach to 0, closer to 0. That means our x can be 0. If 0 become undefined again. Okay, so now that means if you replace x equal to 0 there, right here, if x equal to 0, then this one gonna be open door for up and down here. That means in this case, this is the first condition. When x, absolute x equal to x when x greater than 0. So this is the first graph here. So you plot this one, right? So x equal to 1, x equal to 2, 3, and so on. So this is the graph belong to the first function here. And then this one, if when x less than 0, x equal to negative x. So then if x equal to negative 1, then it's gonna be here. Right, and the x negative 2 going to be equal y equal to negative 1. Okay, so you can see this graph represent of this limit. Then we can answer now the limit absolute x over x when x approaches to 0 will equal to what? Because when you go to the right hand side, you see when you go to the right hand side, y is what? 1, right? So that limit, this one, from when the limit approaches the right hand limit, right, from the right hand side, your limit of this one equal to 1. And then when you leave the limit from the left hand limit here, from the left hand limit, when approach closer to 0, your y is negative 1. So then this one, the two sides of limit when you leave, they are not they are when you leave the both side limit, the value of absolute x over x when x approaches 0 doesn't exist. because they're not equal here, from the left and from the right. Okay, so then let's gonna answer by this one. Okay, from this example, when the limit exists and when the limit doesn't exist, the function, and let's see. Okay, this one is the f, right? And then this is a c. How to say? The limit, just say the limit of function f of x when x approach to c is the number L. Then we can write this one as a limit f of x when x approach to c equal to L. So that means that this one, limit f of x when x approach to c equal to L. Okay, so then from the example, limit does exist and doesn't exist. Now we can find out the definition of limit. Say, if you have any function, right, which have the x approach to c not equal, okay, only approach closer, then the value of the limit will equal to L. So in this case, our c, for example, from this question, our c means 0. 1 over x squared means our f of x equal to L here. This answer is what doesn't exist or plus infinity. Okay, I will give you handout in detail. The handout, and you can study review again from this example. Okay, we have in handout. I will give to you later by inside the class site. Okay, I will post it in there. Then again, from these two examples, exist and doesn't exist, we can conclusion about we have how many types of limit. How many types of limits? We have 3 types. We have 3 types. One is we call two-sided. Another one we can call left hand limit. Another one is a right hand limit.